Welcome to this week's episode of Double E's Talk Tech. My name is Daniel Bogdanoff, and in for Mike Hoffman this week is Brig Asay, and our guest today is Johnnie Hancock. Johnnie started at HP in 1979 working with oscilloscopes in R&D, and he has been working with oscilloscopes since that day. So he might be one of the longest running oscilloscope team members that we have here at Keysight. Is that safe to say, Johnnie?
Pretty close.
Pretty close. Okay. So since 1979, that's a long time. And Johnnie has done a great job of staying up to date with the new cool technology. So what are you here to talk about today, Johnnie?
I believe we're going to talk about wireless power charging.
Wireless power charging of what?
Anything. Specifically, more what we'll see a lot of in the near future will be things like mobile phones.
Okay, great. And how did you get started in wireless charging as a thing?
Well, it was just kind of by accident. There was a customer called in through our support organization, and they were having problems making some measurements. They were trying to make an efficiency measurement on a wireless charging system, and they are a developer of a key chipset, and they didn't understand how to make a power measurement. And some of the key mistakes they were making is at the frequency this charging was running at, 6.78 megahertz, it's really critical to deskew the probes, and they didn't understand that. So I was able to help them out. Eventually, I went out and visited the customer, made measurements. Then I got interested in it, dug into it. We joined some standards organization. I learned more, and it's sort of gone from there.
Great. Why don't you tell us a little bit about the environment of wireless charging and kind of how it works?
Okay. Well, I've got a small example here. This is my mobile phone. This is a wireless charging pad. I plop it down there, it starts charging. Now, this particular mobile phone doesn't actually have built-in wireless charging capability. It's the case that I've stuck it in. It acts as a receiver. So the charging pad is actually, it's kind of like a primary of a transformer. And then inside the case of my mobile phone is kind of like the secondary. So there's a coil here and a coil here. You get them close enough, and then they couple, and they transfer energy from what they call the transmitter to the receiver. It's pretty simple.
Okay, so you said it's like a transformer. So is it magnetic resonance, inductance? How does...
There's two key technologies for this type of charging on mobile devices up to maybe laptops. One is called magnetic inductance, and that is more like a transformer. This one actually is magnetic inductance. It's based on a technology that's called Qi. The other is magnetic...
Is that QI or CHI?
QI.
QI, okay.
Pronounced CHI.
Like the British game show thing, yeah.
They say, they say it's a Chinese word.
Okay, good to know.
I forget what it stands for.
So that's magnetic inductance.
That's magnetic inductance, and it runs at a lower frequency. When the devices are close enough, then they start communicating. Well, initially it's sort of pinging, so it's not using up much energy. So it's out there saying, anybody out there, anybody out there. This guy comes close, it creates a load change. And then it starts generating more signals beyond pings, and then they start talking to each other using load modulation.
That's pretty cool.
Some handshaking to find out, okay, are you an acceptable device, or maybe are you the coffee cup sitting on top of me? If you're a coffee cup, you're not going to talk back, so it's going to shut down trying to charge.
If I were to throw like a spool of wire on top of that, would it register as a load change, or is there like a specific...
It's probably going to detect a load change, but then it's going to be able to detect that it's not a compatible device.
Okay. So that's pretty cool. So there's maybe two main states there. Then there's I think it's called a polling state, right? Where it's...
It could be called a polling state or a power save state.
Okay.
It depends on the specific standard. There's different standards.
Okay.
Now, you mentioned the other main technology. That's called magnetic resonance. That operates at a higher frequency, and it's more highly tuned, but it's also a lot more flexible.
So why don't you expand on that a little bit?
Okay.
Both of those are two good points there.
Okay. This is magnetic inductance. This thing has got to be really, really close. It's got to be almost dead nuts on.
Okay.
Okay, if I'm a little bit off, if I'm too high, it's not going to work.
Does angle matter, or is it kind of a...
Well, on this one,
He's
not
moving his
really.
phone around for those of you on the
It's a
audio.
round coil. It's pretty symmetrical.
Okay.
And one coil, one device to be charged.
Okay.
Okay, with magnetic resonance, there can be more distance, a couple of inches perhaps.
Okay.
And it could be one large coil and multiple devices. We could get your mobile phone and your mobile phone on it. It's going to charge all three at different distances, different angles, and so on. And so what that enables is you could take this charging pad and mount it under the table where you don't even see it.
Okay.
Now, this is not working now because this is not magnetic resonance.
Right.
We've got about, I don't know, 2 inches here, and it's just simply not going to work. If this was magnetic resonance, it would work.
Interesting. I assume there's table types that would work or wouldn't work based on what they're made of and that type of thing.
I think so. Wood works, glass works. If it's metal, it's not going to
Going to
work.
be a problem.
Yeah,
Okay.
they say stone will work. So like a kitchen counter, it's going to be okay.
So will people start integrating that into non-electronics type devices? And is that happening?
It's already happening. In fact, in some of the standards organization, you have most electrical standards organizations are made up of chip vendors, computer vendors, test and measurement vendors. But wireless charging, there are furniture makers, coffee shops. So it's going to create a whole new infrastructure where wireless charging pads can be built into furniture. Now, even magnetic inductance, you'll see it built into furniture. It's just going to be at the surface. So like this thing might be down embedded in this tabletop at the surface. Whereas magnetic resonance, you could take an existing desk and easily mount it under it. Whereas with magnetic inductance, it's going to take some customization on the piece of furniture. So I believe you'll eventually see places like Starbucks. You go in, you set your mobile phone down on the counter or the table, and your phone will charge. Now, it's probably not going to be free. Some other things that might go on is, remember, there's communication back and forth between the transmitter and the receiver. They're also going to take your credit card information and charge you per minute of charging.
So is there spec'd in the ability to transfer non-power related information? Is that part of?
I think so. I know at least the one standard that I'm a little more familiar with, AirFuel, they've got a mechanism, I don't know if it's fully implemented, for sending information to the cloud and collecting that type of data. Now, I mentioned with magnetic inductance, the way they communicate back and forth is through the actual AC signal itself that's being load modulated.
Interesting.
Now, with magnetic resonance, it has a parallel communication path. If this was magnetic resonance, charging is happening through the AC signal,
Okay.
but the communication path is a parallel path, and it's Bluetooth.
It's Bluetooth. So it's Bluetooth protocol, or it's actually a Bluetooth connection, and it will like automatically pair.
I think that's what
Okay.
it would do. I'm not exactly
Interesting.
sure.
So this could be in the future, a pretty big security concern news item. You know, someone hacks into wireless charging at coffee shop A, and
I guess that's possible. I don't know.
that's interesting. I didn't know that there was any sort of non-power related communication happening, but I suppose it makes sense to build that in.
Yeah. So furniture manufacturers, coffee shops, restaurants, that's one infrastructure. Another is automotive. You know, in the future, you're going to be able to get in your car, set this down somewhere on the console or some sort of pad, and it's going to charge. Now, myself, I'm not a salesperson. This thing never goes dead. I can go all day. When I get home, I've got this sitting on a table next to my sofa. I just lay it down and charge.
Okay.
But salespeople that I work with, they're always dealing with dead batteries, searching for a place to plug in their mobile phones, get them charged. And so this will really improve that a lot. People, when they get in their car, just set it down, don't have to plug it in. Now, why is this so much better than just plugging a cable in?
Right.
Okay.
Because if you have to be right on top of the charging pad to use it and to get your battery charging, then is it really that much of an advantage over having to plug it in, other than the physical act of plugging it in, right? It seems kind of...
I would think if you had wireless chargers everywhere, you don't need to worry about which cable, where's my cable to go and charge it. I can just go put it on my coffee desk. I can go to my car. I don't have to have another cable for my car. At my desk at work, I can just go put it down.
But you have to
and
have
so I never have to worry
charging
about
pad.
cables.
Okay.
Eventually, that infrastructure will be there, I believe, and they will be everywhere. They're not everywhere today. But even if we don't consider charging pads everywhere, many of them hidden, you don't even see them, it's amazing how spoiled we become. My wife bought this for me. And
At a furniture shop, I should
at
add.
a furniture shop, and by the way, they have models that look almost like this that are embedded in their end tables, side bed tables, even the bases of lamps. So you go to bed at night, you just reach over and say, this is your lampstand. You just set it on your lamp.
See, look how nice that is.
Okay? But as I was saying, it's amazing how easy we get spoiled. I get home in the evenings, I'm kind of a couch potato, sit down and watch the big screen TV, and next to it is a side table where this thing sets, and I just set it down. And then, they say something on TV, and I say, oh, I got to Google that. I just reach up, punch it in, set it down. Whereas if I had a cable plugged in, it's a two-handed operation.
It's super annoying.
Okay.
It is.
So you can have coffee in one hand, pick up your charge. Basically, it's so Johnny can drink his coffee, is what I'm hearing.
When you look at the different standards, like how far do they think they're going to get it to where you can charge? So is it eventually, do they want to get to where it's feet that are distance away, or as opposed to just 1 or 2 inches? I'd read about a company that you could keep your cell phone in your pocket, and that up to like 30 feet, they're looking at being able to go in and wirelessly charge different devices.
That's right. There's a couple different organizations working on that type of technology where you have something mounted on the wall and it's going to supply energy for the whole room. And you can go to YouTube and Google wireless charging videos, and you'll see all sorts of videos. You see examples of this, and you'll see them in a room actually powering up a full PC, powering up lights, everything. Now, it sounds a little scary. I don't fully understand it. There's one guy that he shows you might find the YouTube thing. He takes a transmitter and he holds it up on this side of his head, and then he takes a light bulb. Now, I'm sure it's an LED light bulb, and he holds it up on this side of his head.
I'm going to stop you right
and
there.
It lights up.
That video was fake. Let's pause real quick. Johnny and I were thinking of different videos. The video Johnny's talking about is not fake. It's a TED Talk about wireless charging given by one of the inventors of wireless charging. So I encourage you to go check out that video. Also, Johnny specifically asked me to grovel in my apology, which I don't think I'm going to do. Sorry, Johnny. But go check out the video he talked about. It's pretty cool. Carry on. I'm sorry.
Okay.
It is, yeah. So I was opening up my mail this morning, and I get NASA tech briefs. They talk about new technology that people are inventing, and it's part of a government program where NASA's actually required to divulge information that they've learned in the research. So it's pretty cool things. It's free. You should check it out. But they had an article about magnetic resonance charging, and like you were talking about, it was feet and feet or tens of feet away with repeater systems and all that using magnetic resonance. So
Yeah, they talk about repeater systems being, say, under the carpet.
interesting. Okay. So how does a repeater system work? Are you familiar with those at all?
No, I'm not.
Okay. Yeah, so it sounded like there was some sort of receiver coil, and then it would reprocess the information because, like you said, magnetic resonance has to be very finely tuned. So how do you go about tuning a device? What does that look like?
Well, they use a lot of different test equipment. Now, one of the key pieces of test equipment for magnetic resonance is a network analyzer, because
Okay.
these are very highly tuned circuits.
That makes sense.
So they extract S parameters and Z parameters and so on.
So it's kind of an impedance matching type system.
Yes.
Okay, interesting.
But the oscilloscope is another key tool for characterizing the performance of a system.
Okay. So you've been on site with a number of engineers developing wireless charging systems. What are they struggling with? Why don't we have this technology now? Like, why is it not widespread?
I believe it's going to take off in the next couple of years. I think we're at the knee of the curve right now. You can go online, you can find, the furniture store where this is bought, they got a lot of different versions. I'd say the thing that's slowing it down the most is the standard. There is no single standard. There's a standards war going on right now. And that's going to have to shake out. And then I believe once that shakes out, there'll be one winner.
Okay. Do you think, without maybe naming a specific spec, will magnetic resonance win or magnetic inductance win, and why?
Two different things.
Sure.
Which one do I think should win? I think it should be magnetic resonance because of the flexibility of it. Which one do I think will win? Probably magnetic inductance, because they're first to market and the Qi technology is much better known. So that's
Okay.
And by the way, the organization that has the Qi technology licensed, it's WPC, Wireless Power Consortium. I think that's what it stands for. They are also working on magnetic resonant technology. And the other organization, there's two key organizations, is AirFuel, which was a merger between two different previous organizations, A4WP, Alliance for
Okay.
Wireless Power, and PMA, Power Matters Alliance. They merged. Power Matters Alliance had magnetic inductance. A4WP had magnetic resonance. Now AirFuel has both. So they're
Okay.
supporting both standards. And what a lot of technology companies are doing today is they're implementing multiple standards in the same device.
Really?
Yes.
So you're speaking specifically to mobile type devices, or are you talking about
Yes.
electric vehicles and that type of thing? Okay.
I'm not sure about electric vehicles,
Okay.
but mobile devices, they're implementing multiple standards. Some of the chipsets support multiple standards, so that if you, let's say you go into a Starbucks and they have one particular standard, your mobile phone maybe supports any of it, and you set it down and it's going to figure out which one it is and then adapt
Okay.
it. Now, the trade-offs of that is it's going to drive the cost up a little bit. It's going to drive the size up a little bit. That's
So-
why I believe one of them has got to win.
That makes sense. So is there silicon that people can license and put the IP in their devices? And because I imagine batteries aren't really changing. I know that you can buy aftermarket batteries with extra stuff built in, but is that IP that you just license and throw in your device? Are all the companies trying to develop their own?
I don't know.
Okay. Interesting.
So out of curiosity, when you look in the standards, who are the loudest influencers of the consortiums? Are they the manufacturers of like the furniture stores, or is it the guys actually building who seems to be influencing the standards
What
the most?
group of people?
Yeah, what group?
Don't know.
Okay.
Okay. I'd expect there'd be a pretty good back and forth, but that the device manufacturers are probably the leading voices in those consortiums.
Yeah,
because they're the ones who actually have to make it happen, right?
Yeah, I was wondering who was, if it was a price thing, a functionality thing, who was, at the end of the day, who was winning this.
That makes sense.
Now, there are different trade-offs besides, I mentioned magnetic resonance, sponsored by AirFuel, has more flexibility. Set it here and it's going to charge.
And multiple devices is a pretty big
And
thing.
multiple devices, assuming it's a large enough coil. The trade-offs are the efficiency is not as high as magnetic inductance, and the cost is higher.
So that was my next question, was efficiency. How efficient electrically is it? When I have this, you have this plugged in next to your sofa. How much power am I burning every day just by having this technology?
Okay, the typical efficiency of that stage of charging is somewhere 65 to 80%, depending upon the technology.
Okay.
Okay, now, I was looking at some of the specs last night to get ready for this. I wanted to figure out what was the wattage of this thing.
Yeah.
5 watts.
Oh.
So if I lose a watt, if I lose 2 watts, I don't care.
Yeah, that makes
Okay?
sense.
Now, if you talk about wireless charging efficiency for something bigger, let's say
Like a car.
an electric vehicle, now 10, 20, 30% inefficiency can be a big deal.
Is temperature an issue at all? Are you like where does the loss go?
Well, any kind of loss is going to create heat. So it goes up in the air, helps heat this room.
Okay.
So it's not wasted.
It's kind of dissipated in the environment, more or less. Interesting. How safe is it? So, are there government regulations on how much wattage you can spit out of one of these, or is there? I'm sure there must be.
Well, this has both UL and what's the Canadian ones? CSA or CE.
Okay.
It has all the
Okay, so
stamps of
it has
approval.
to match all the emissions
Yes.
requirements. Interesting. I wonder if there, in the future, I expect there probably has to be some sort of, allowances for wireless charging. Because if I'm going to pull an electric car into my garage, or even on a road trip and try and get it charged up in 15 minutes, like, a lot of electric vehicles are expected now, that's going to be a lot of power being dissipated.
Yes.
I had a professor at Texas A&M who he said, I spent 15 years trying to figure out what electromagnetic radiation does to people, and all it does is heat stuff up. So before you guys are freaking out about how much power is coming out, at least one guy out there, he was president of IEEE and all kinds of things, thinks that it should be fairly safe, but I imagine there may be interference with other devices and that type of thing in the future. It'll be interesting to see.
Yeah.
So what?
Now-
Yeah, go ahead.
Now, wireless charging is very similar to near-field communication.
Okay,
And
NFC. Yeah.
NFC. Almost all of our modern-day mobile phones have built-in NFC.
Like Apple
So-
Pay, Samsung Pay.
That's right.
A lot of
So you go up to a payment terminal, you just get it close, again, close, or tap it. There's a transfer of not only information, but energy as well. And so it's very, very similar. And so we're not too concerned today about NFC waves harming
Right.
anybody.
Yeah, that's a good point. Interesting. So looking into the future, I think there's a lot of really interesting applications for wireless charging, especially if we're talking about the 10-foot type or more radius of charging, especially when it comes to wearables, which are getting more and more important, or even medical devices.
That's right. So you consider if you have a pacemaker, years ago, if you got a pacemaker implanted, which years ago they were, like the size of a hockey puck or bigger, and a big portion of that was the battery. And when the battery went dead, surgery, pull it out, put in a new one. I don't know what they're doing today, but if they're not already putting rechargeable batteries, maybe they've got wires coming out to charge them, I don't know. But in the future, if not already, I'm sure they wirelessly charge them.
Yeah, and then if you can just put a charger into your house and never have to worry about, as you sleep at night, your implants are charging up.
Okay.
That'd be great.
Also,
Or
you talk
watches
about
or-
medical applications, not just things that are implanted. Just go into any hospital or a doctor, medical center. The nurses, the technicians, they're running around with all sorts of specialized portable devices, mobile specialized devices that operate on a battery. They're using them all day long. And to have to plug in each individual one versus, well, let's take this one back, set it on the pad, grab a new one. Take this one back, grab a new one, as opposed to plug, unplug, plug, unplug.
How much power can you transfer? So is it reasonable that in the next maybe 20 years that I don't even have to plug much in. So like the soundboard that we have, I wouldn't have to plug in.
Maybe.
That's pretty cool.
I've seen demonstrations
Okay.
of like a TV and a monitor running.
So someone out there, here's an idea for you. You can create an adapter basically for plugs that is just a wireless receiver, power receiver that you stick into a standardized power port, and you could make non-wireless power things wirelessly powered.
I like it.
So there's an idea for you. Good luck.
Well, you think about your
Remember me if you create that. Yeah.
Only, Daniel, you only need 5% of the proceeds.
Sure.
Well, you think about your office where you've got a computer, printer, scanner. All those could be picking up power off of some sort of charging pad, and not so much charging a battery as opposed to just delivering enough power to power this thing. Because like your printer, you may not really want it to be battery operated. You want less cables. So you've got a wireless connection from your PC to your printer, and you also have a wireless connection to the power source for the printer, scanner, whatever.
That's pretty cool. And we're actually out of time for today. It blew by.
Wow, time flies.
Yeah.
When you're having fun.
wirelessly, yeah. So at the end of every episode, we have predictions. So Johnny, do you have any predictions for wireless power going forwards?
Well, kind of like what I went back to before. I believe within the next 3 years, you're going to see wireless power, especially for mobile devices, everywhere. And I think also for, in the next 10, 20 years, we'll all be driving electric cars, and our garages will be equipped with wireless chargers. But as we talked about, I think they've got to be a lot more efficient.
Okay. Brig, I'm going to put you on the spot.
So my prediction is if I'm a power cable company, someone that makes the power cables, I'm out of business in 10 years, that everything goes wireless charging, including my refrigerator, and that even houses don't even have connectors anymore, that
Interesting.
everything's wireless charged.
Okay, that's similar to mine. And mine is that we're going to see a shift in how power is delivered residentially and corporately, I guess, where so much wireless power will take over our daily lives so much that pretty much everything we have will be wirelessly charged, and they're going to have more flexibility in how they deliver power to buildings. They can be more efficient, do whatever they need to do.
And we'll all glow.
All glow.
And we'll never have a dead cell phone again.
That I'm looking forward to. So that's all we have time for. Thank you for tuning in to Double E's Talk Tech. Thank you, Johnny, for being here. It's been a pleasure having you. And Brig, thank you for being here as well.
Always an honor.
I'd encourage you to go check out other Double E's Talk Tech episodes, both on our YouTube channel and in the podcast, your favorite podcasting engine. And if you're interested in testing and you're working on wireless charging, you can check out some of Johnny's app notes, and there's more on Keysight.com about how to actually go about testing and implementing wireless power and charging in your designs. That's all we have time for. I'm Daniel Bogdanoff, and we will see you in 2 weeks.